Hello, so today we are going to do weekly contest 383, which is this weekly contest. The second problem is minimum time to revert word to initial state. So basically here we have a word and we have an integer k. So a word like this one, and the k value can be 3, for example. And the rules are that every second you must perform one operation, and this operation consists of 2 steps. The first step is to remove the first k characters. So in this specific case here, the first step would mean removing the first 3 characters, so A, B, A, and then you can add any k characters to the end of the word. So you can add whatever you want, three characters. They can be whatever characters you want, okay? And the goal of the problem is, what is the minimum time that it will take us to go back to the initial word state, to this initial word, using these operations? We have to do at least one operation, right? Because it says greater than 0. So you can't just keep the word and not do any operation. That would mean for every word, the solution is 0, right? And the time here is the number of operations you do, because every second you do these 2 operations. So let's see the first example to understand better. So in this first example, what we can do is, in the first second, we can remove this ABA and then add BAC, since we have the choice for whatever to add. And now we end up with this. And then in the second operation, or the second second, we remove the first 3 here and add some 3 at the end. So those 3, let's say we add ABA. So if we add ABA, now we have ABAC, ABA, which is exactly the initial word we have. And so we only need 2 seconds, and so that's what we return, okay? Now, if you look at the constraint, the length of the word is up to 50, and we only have lowercase English letters. And k can only be up to the length of the word, so it's up to 50. So this tells you you have room here to do an O(n) squared solution if you need to. But let's see how we can tackle it. Okay, so let's see how we can tackle this. So here we have the first example. The key thing to think about to solve this problem is that the problem says to you that you have to remove the first k characters, but once you remove it for that specific second, you can add whatever lowercase characters you need to, okay? And so the intuitive thing first that you may think about to do is, okay, let me actually add specific characters. Let me think about what are the best characters to add here. So let me think, is ABA the best characters to add? Is CAB the best characters to add? And maybe you would think you want to try them or something. And maybe you would say, let me try only the characters that are in the word. And that would be like reasonable, but that's the wrong approach to think about here, because you are allowed whatever you need to here. So let's just assume like we will count the seconds, but we will add whatever will get us to the initial state, and we will think about that later. Now, so that's the first thing. So whatever we need to, we can add here. So that means basically, if we remove this and to get the string, we need to add ABA. We will have added it, but it doesn't matter what we add. It just matters how many seconds. We can add any characters we want, okay? I hope that makes sense. Now, the second piece to think about is, there are some cases where you need to stop. You don't need to replace the entire string. What are those cases? Well, in this specific case, if you look at it, what we have is that this, this character here, we had A here, so we had A here. So this A here actually matches this A here. Okay? So why does that matter? Let's see. So why does that matter? If you look at this, let's say we remove ABA, the first operation, and then we add whatever we need here. Let me just remove this, and then we remove the second operation. So now we are at 2 operations. And now we have this A. Does it make sense to remove these 3 again? That's the key question here. Well, what's our end goal? Well, our end goal is to get back the original state, which is ABA, CABA. Okay, so here we added another 3 for removing CAB, right? Does it make sense to remove these 3 here? It doesn't, because you already have A here, and you could add here whichever characters you need. So let's just add ABA. And you could add here whatever characters you need. So let's just add CAB. Yeah, so we can add, so this is 4, we can add here, so 4, we can add then CAB, CAB, and then add A. And now we have the actual string, because it doesn't matter what we add here, okay? So what does this tell you? This tells you that if there is a prefix, like in this specific case here, if there is a suffix here that matches the prefix, actually it's better, that matches some sort of prefix, we shouldn't remove that suffix. Okay, so any portion or any suffix from the original or the word that matches the prefix, we should keep and just count how many operations we needed for the rest. Now, one caveat here is we need to do at least 1 operation. That's what the problem tells us to do. We need to do, so we would have to remove at least the first 3 and add the second 3. But then after that, if we have any suffix that matches the prefix, it's useless to remove it and then add again. Why? Because that would increase your number of operations by 1. Even though you would have found the match anyway, you would have come back to the initial state anyway, right? And so it won't be the minimum, even though you would revert to the initial, even though with less than 1 operation, you would get back to the minimum, you would get back to the initial state, but with a smaller number of operations, right? So that's the key idea here. And I think it will be even more clear if we do some coding and just print the state for each k portions we remove, and you will see why that works. But that's the core idea here. Now let's jump into the code. Okay, so let's see how we can do this. So first let's just have a couple of housekeeping. So we need this, which is basically just the number of seconds, and since the problem says that you have to remove at least, you have to do at least 1 operation, or at least 1 operation. So we'd have to start with 1. And then what should we do? First, I want to show you just how do you detect that a suffix, okay, basically the suffix of the remaining of the word matches prefix of initial word, right? Because that's what we want. Once we find a suffix that matches the initial, some portion, or that matches a prefix of the initial word, we shouldn't do any more operations. We should keep that and then just count how many did we had to remove so far, right? And how many we did had to remove so far is count, right? And so we'll just for now do just a while true, just so that we loop, but we will stop once we find a suffix that matches, okay? So stop at suffix of remaining that matches prefix. When we find basically a suffix that matches, okay? And so to do that, what do we need to do? Well, we need to, how do we find the remaining portion here that we have so far? Well, the remaining is just, the count is how many operations we did, and for each operation we remove k, right? So the remaining is going to be after basically removing count times by removing how many? K characters. So after removing k multiplied by count characters. So how do we get this? Well, this is just the word. And then removing, we could just, that means starting from that index in Python all the way to the length of the string, right? Which pretty much is also just this, okay? Now, how do we find the prefix that could match this? Well, it has to be the same length. That's the first thing. So prefix that could match, it has to have the same length. What is the length of this one? Well, the length here is from k multiplied by count to n. So it's n minus k multiplied by count, right? And so the prefix length has to be n minus k multiplied by count, This is the prefix length. And so since we know the prefix length, we know the prefix has to start from the first position, then the prefix is just 0 to the length that it needs to be, right? And in Python, you can just write that like this, okay? So now we know what is our suffix and prefix. So let's just print them so you can see what's going on. So I'll just print them with some text here. So basically we'll say the suffix after removing k count times is going to be this, and the prefix that may match it, right, which has to be the same length, is this. Now I do some just edge case protection, which is if this here, right, is bigger than n, so if we do a lot, if we remove everything and then do one more count, then we want to just stop at 0, right, and then it would be empty string, right, and then empty string, then it would be equal, and we can just return the count, which would be basically just removing everything and then adding back the initial string. Okay, so right now we'll just print this and do count plus 1. Just so that every operation will increase it. I want here just to be able to stop. I will stop when we reach maybe n plus 1, just to be able to stop. And so let's just see what this looks like. Okay, so for this first example, what happens is, what is the suffix after removing just one time, the first time? Well, we remove this, so the suffix is CABA, right? Now, what is the suffix after, and then the prefix that could match is just the same length, but from the beginning. So the same length is 4, and so it's this one. There is no match, so that doesn't work for us. But then when we do the second removal, we should remove this. Now we have A remaining, right? And then what is the prefix that could match? It has to be the same length, and so it's just this A here. And that matches, right? Those are equal. And so what we actually need to do here tells you that what we actually need to do here is we just need to check if there is a match between the suffix and the prefix, then we should return. Because we shouldn't do any more operation. As we said, the ones that we already removed and added back to the end, we can add the basically whatever we need, and so we can add the rest of the word, right? And so here we only need to check that the suffix here, which is this, matches the prefix, which is this. And if it does, then we can just return count. Otherwise, we try to do more operations, okay? And at some point it will, because if k multiplied by count increases more than n, then this would be empty, this would be empty, they would be equal, and we'll just return, right? Because when we remove the entire word, we can add back basically the initial word, right? Okay, so that's the idea here. Now let's just keep looking at see what happens through this printing. And so when the prefix is equal, if we do more, then it will just be empty string, it would be equal. So we should just stop when it's empty string, which this would make it stop, okay? Now let's just take a look at the second example to drive this home. So what it's for. So first first time we remove this, we have ABA remaining. And you can see already what's the prefix that could match is ABA, right? Which is equal. And so we should just stop here and return 1. Okay. And same thing here, 2. So first time we remove AB. And so what's remaining is ABCBAB, so that doesn't match. The second time what's remaining is this, it does match. Okay. ABCD, it does match. So in that case, let's look here. Okay, sorry, here we remove just 2, not 4. So if we remove 2, then we have this thing which doesn't match. If we remove another 2, we have ABCD, which does match. It doesn't match actually because there is a B. Sorry, it doesn't match because there is a B and DD here. So it doesn't match. So we'd have to remove more CD, AB. It doesn't match. So we'd have to remove the entire thing. Okay. And so that would be detected by this as well. I hope this is clear. Now I think that's it pretty much. We could run this and we can submit and it should work. and it does work, okay? Now, one other alternative way you could do this, if this was hard to come up with, since you are just looking for a prefix, you could just check if the word actually starts with this, if it has this as a prefix, if it has the suffix as a prefix. And that will guarantee that it's the same length. That should also work. So if we run this, submit, should work, and that works, okay? Now, in terms of time complexity, as you saw here, this goes up n times. It doesn't go more than n times. The worst case is going to be n times when k is equal to 1. Okay, and so pretty much this is an event solution. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.